Now recall that an empty set is a set where there are no elements okay? So we don't have any elements here. So what this is saying, much less elements in A that do not belong to B. Because we cannot find an element in A that is not contained in B, we said B is 6, 7, 8. This means that A is a subset of B. Therefore, the answer is yes. And furthermore, to end with this example 3 here, this is going to be key. I know we will cover this some more in class. The empty set is a subset of every set. The empty set is a proper subset of every set except itself. Okay? The empty set is a proper subset of every set except itself. All right, so before we finish the last example, I want to talk about some special cases. The number of subsets. All right, so just to put some clarity to the subsets, then we're going to finish out the last example. So for example here we have number 1, an empty set. How many elements will we have in an empty set? 0. List all of the distinct subsets. Well, we just have this empty set. The number of subsets that we have, just 1, because we were only able to list all, by listing all of the distinct subsets, it's just 1. 2, we have set A. How many elements do we have? We have 1. What are those distinct elements? Because remember, the empty set is a subset of every set. So we have, of course, set A, and then we have its empty set. So the number of elements, we have 2. Number 3, do another one. A, we have set A. B, we have how many elements here? 2. List all of the distinct elements. We have AB, we have A, we have B, and we have the empty set. So how many is that all together? Number of subsets. We have 4. Let's do one more. A, set A, B, C. How many elements do we have here? We have 3. Let's list all of the distinct subsets. We have A, B, C. We have AC. We have AB. We have BC. We have A. We have B. We have C. And we have the empty set. How many is that all together? We have 1, 2, 3, 4, 5, 6, 7, 8. If a set contains n elements, how many distinct elements can be formed? And this is what's going to lead us into our example 4, the number of distinct elements, distinct subsets. So the formula that we're going to use, the number of distinct subsets of a set with n elements is, now this is a typo here, our formula is 2 to the n power. Because look at it. Look, what are we doing here? If you notice with the number of subsets, how are we getting these out? Listing all of the distinct subsets by this table that was just drawn. And then the number of distinct proper subsets of a set with n elements. The formula is, typo again, 2 to the n power minus 1. Alright, so example 4, find the number of distinct subsets and the number of distinct proper subsets for each set. Example A, we have A, B, C, D. How many elements do we have? We have 4. We have A, B, C, D. That totals to 4. So let's find the subset, the distinct subset. We're using 2 to the n. Let's plug 4 in for the variable n. So 2 to the 4. We have 16 distinct elements. You can draw these out. A, B, C, D. You have A, B, C, D. We have A, B, C, A, C, D. We can keep going and going, but this is the formula that we can use, especially when you start having sets that are greater than at least 3. Now, the proper subset, our formula 2 to the n minus 1. We have 2 to the 4th power minus 1. 16 minus 1, which gives us 15. So we found the distinct subset, the distinct proper subsets. Letter B. For all x is such that x is an element of natural numbers, let's draw the n out, and 3 is less than or equal to x, less than or equal to 8. So let's identify those numbers, those natural numbers. We have 3, 4, 5, 6, 7, 8. So what will be our our elements here? N is what? We have 1, 2, 3, 4, 5, 6, 6. So let's find the distinct subset. We have 2 to the 6th power which gives us 64. And then our distinct proper subsets, 2 to the n minus 1. We have 2 to the 6 minus 1. That is 64 minus 1. That is 63.